All right, good morning and welcome, or welcome back if you joined us yesterday. This is Metal Forming Magazine and PMA's 5th annual Internet of Things experience for manufacturers, and this year again presented as a series of educational webinars. I'm Brad Kuvan. I'm the editorial director of Metal Forming Magazine at PMA, and I'm pleased to serve as your moderator today and throughout the rest of the webinar series today and tomorrow morning. As mentioned during previous sessions, this meeting and all of the others in the series are being recorded for archiving, and the recorded events will be posted to our website along with the presentation PDFs, PowerPoint presentations at the conclusion of the webinar series. We'll get those up on the website either Friday or early next week, and then we'll send out an email to all of you when the recorded webinars are available for viewing online. Also, all participants in the meeting are in listen-only mode. That means that the speaker and other listeners cannot hear any audio from your site during the program, but you can communicate with us by submitting any questions or comments using the question box, which is located in that right-hand control panel in the go-to screen. You simply type your question and use the pull-down menu to send that question to an organizer. You'll also use that same question panel to ask questions of our speakers at the end of each presentation. Lastly, before we go ahead and get started, I want to thank our event sponsors, Komatsu and UNIST. Without their support, we would not be able to bring educational events like this into you. So much thanks to Komatsu and UNIST. So now it's time to begin this morning's webinar session. And we begin with a talk focused on how small to mid-sized manufacturers can build learning organizations prepared to manage the Industry 4.0 disruption. We're talking IoT as well as additive manufacturing and other Industry 4.0 tenets. So our first speaker this morning is Pavan Mazumdar. He is the CEO of Automation Alley and also the founder of PCS Insight LLC, which is a company that teaches leaders of growing companies how to increase profits through intensifying happiness and reducing friction in the workplace. Leveraging his experience with workplace cultural change, Pavan created Automation Alley's competitive Industry 4.0 transformation program and Industry 4.0 assessments. And in addition, Automation Alley recently completed its 2021 Technology and Industry Report, which is a deep dive into adoption among small and mid-sized companies. And Pavan will discuss with us today some of the findings from that report. So please welcome Pavan. Pavan, you need to go ahead and share your screen. And we can't hear you. Pavan, you're muted, I think, or your audio is turned off.
Yeah, can you hear me?
Yep. And you need to share your.
Yep, I'll share my screen right away. So first of all, thank you so much for Metal Forming Magazine and the PMA for this opportunity. As Brad mentioned, my presentation is on Industry 4.0 transformation lessons learned, and as he mentioned, our focus really is the small and medium-sized manufacturers. So Automation Alley, we're a nonprofit. We're in the state of Michigan. We are the Industry 4.0 Knowledge Center for the state of Michigan, and we've been on this path to help our ecosystem navigate the complexities of Industry 4.0 since about 2016. And along the way, we've learned a few lessons. So our core focus is really just Industry 4.0, but we really focus on manufacturing as our beachhead because that is actually a very large component of our GDP in the state of Michigan. So the first question is, what is Industry 4.0? And it's the way we look at it is this collection of technologies that is around digital meeting physical. And so you'll see this list, but really the core of this is this digital thread. It's becoming a software organization or thinking like a software organization. And the first question that I like to point out is, why should you care? Why should a manufacturer that's done really well over maybe 30 years, 50 years, in some cases in our state we have companies that are over 100 years, why should they really care? And the reason is because Industry 4.0 is the biggest disruptive force for organizations that we have seen. It truly is a revolution. It's not just a a little a shift. It truly is a quantum shift, and we'll see why as we go down this presentation. But the first question that I'd like to kind of point out is, why do companies get disrupted, right? So what happens is when companies become successful, they end up having an operational focus. They become really good at doing something. And then sometimes there happens to be a market shift. And if they're not ready to kind of navigate that market shift, then it has deep impact on business viability. So let's take an example. Kodak was in the film manufacturing business. They defined themselves as we make film. We are a film manufacturer. And even though in 1974, Kodak actually is the company that owned the patent for inventing the digital camera, they missed the digital boat. And so what really happened at the time was that Kodak was organized for film production, and it needed to transform into a hardware business. And so there was a fundamental shift. That's that market shift that we talk about. And when we see that happening, that's when the alarm bell should kind of go off, and we'll see at the end of the presentation a case study where this is potentially happening in our industry as we speak. So with that, what's the impact of Industry 4.0 on business? So we like to call it the 4 Ds of digital disruption. The first one is what we call disintermediation. What that simply means is that when you start having digital information being ubiquitous and available, the intermediary often gets taken out of the equation. So the middleman often gets taken out of the equation. And what gets replaced with it is what we call these massive platforms. So you'll kind of see this in the way Etsy has developed a platform, Amazon has developed a platform, eBay has developed a platform, and they become sort of this foundational intermediary, but the middlemen in markets, they're often kind of taken out. The second thing that we see is what we call dematerialization. And that is the tendency for things to become smaller and smaller and smaller, and nowhere more so than in audio. The first audio recordings were made on wax cylinders. They were huge. Then we moved to vinyl. They were much smaller, greater density. From vinyl, we went to tape. Again, greater density, much more easy to use. Then from tape, we went to optical disc. From optical disc, we went to storage. And from storage, now actually we have cloud storage, and the music is now available to us digitally as streaming. So that's an example of dematerialization. Another D that we like to talk about is demonetization. What demonetization means is that as more and more digital technology permeates the activity, if you will, money gets kind of taken out of the equation until and on such point where we've actually proven value. So an example of demonetization would be how Facebook is able to offer tons and tons of value to a customer or to a user, but they're not actually charging any money. Now, in that particular case, the user is actually the product because the user's behavior is being monetized behind the scenes. So it's very important to kind of understand how that all fits together. Another example is the freemium model, right? The freemium model of delivering digital technology is an example of demonetization, where tons and tons of software is available free of charge, and then you only pay for some premium services, but there's a ton of stuff you can actually do without necessarily having to pay for access, right? And then the last one, which we find the most important and the most interesting, especially as it pertains to small and medium-sized businesses, democratization. Democratization is this notion that if you have the right technology solution, you don't need huge capital scale, and even the smallest of players can make a mark in this new world that's coming around. And that to us is the most promising, especially because our small and medium-sized organizations tend to be the most nimble and in a lot of cases most innovative. Yes, they don't necessarily have the resources in all the cases, because their customers who might be larger organizations have the capital access, but what they lose in those, they can make up in innovation and being scrappy and nimble and move fast. And so this to us, at least at Automation Alley, is the most promising, which is that even the smallest of organizations can have access to the best technology and the best innovation. The other thing that we see is that when you start having technology moving, the technology moves way faster than the business models, and there's a danger in this. And the danger in this is that we see a technology and we look at it and we are like, oh, this is kind of cool, but we don't necessarily keep at it, and the business model catches up slowly, but we might have shelved the technology or not paid attention to it or not thought it was viable. We'll come back to this later on in the case study right at the end of the presentation, and that's probably the one biggest takeaway that I would offer you is that we really need to pay attention to this, that as you're watching technology evolve, always keep an eye on it. Keep an eye on when that commercial viability might be likely to happen, and make sure that you're ahead of that curve and not necessarily discounted just because it's in its nascent stage. The other thing that we see often in business is that financial analysts tend to undervalue physical assets and overvalue digital assets. And so what that means is, if you compare, for example, in our state, right, we have the big three automotive companies, and their market caps compared to someone like a Tesla are a fraction. And it causes a lot of heartburn, not only in the business community, but also for policymakers. But you can explain it with this, where Wall Street is valuing these companies substantially lower because they don't necessarily have that digital experience. And what the signal they're saying is, you have to get on that digital train if you want to be valued at the same level that some of these upstarts. The same thing, by the way, is true for small businesses as well, especially if you're a business that's looking for an exit, if you're a small company that's looking for an exit, the same valuation dynamics are going to impact those small businesses as well. So it's not just for the large publicly traded companies, it's also for the small business, because the acquirer, especially if they're going to be a strategic acquirer, is going to look at what is that digital thread, what's that capability, what's that growth potential beyond, not what's happened in the rearview mirror. The other thing is that valuation is driven by customer experience and product, not process. So often what's happened when we talk about industry, the previous industrial revolutions, which is 2.0 and 3.0, which is all about assembly and automation, is we were trying to figure out how do we manufacture something, and the product sort of came second because manufacturability was the most important, right? Because that's what was the most complex. Now with the digital technology, it's the product experience that's going to lead, and that's what's going to drive valuation of companies, both on the small and on the large scale. So what is the challenge of our times? When we look at Industry 4.0 and along these past 5 years, as we've been on this path, the biggest challenge that we see for small businesses and also for large in a lot of cases is to overlay what we call a digital mindset on a physical business, because we don't have the luxury of a pure software business that's only making a software or an IP or an intellectual or some kind of an information product. We're still continuing to make physical goods. How do you overlay this digital mindset on this physical business? And that's the important thing. And so we have a couple of thoughts on how we might be able to do that. But to really kind of understand how to do that, we need to know, what is this difference, right? What is the physical and the digital? What do they look like? So on the physical side, we design something, then we learn how to scale it. We're all about consistency, because that is basically the mantra of manufacturing. Change tends to be incremental. Change does not tend to be this quantum shift. And access is serial. So if we're working on a component, especially if it's going through some kind of an assembly line, only one piece of technology or one piece of processing or one technology can be working on that product. And what we value is throughput. On the digital side, it's a completely different picture. We design to scale. In other words, the design already embodies in it the scaling. We value variability. So for example, if you're going to a website and it's the same thing every single day, you're not going to go to it after day 2 or 3 because nothing's changed. Change tends to be exponential. access tends to be parallel. What we mean by that is, let's say you're working on a data file or some kind of piece of information. You can have multiple algorithms, software, whatever, working on it, which are really the processing tools of the digital world. And what we see is iterative design. Designs it's all about the iteration. How can we iterate? And we'll look at some examples of some companies that have done this, kind of meeting those two, bringing those two together. In terms of business models, physical business models are about ownership. The product tends to be static. It's about a monetary exchange. It's about exclusivity. If I own a product, nobody else can own the product. And the business models, because no one can really get a foothold, tend to be competitive in nature. On the digital side, it's about the experience. It's about a service, not so much a product. It's about the attention that we're going to monetize as opposed to the money per se. Now, of course, money does come to the picture down the road. The experience can be shared. And so, for example, when I'm driving my car, I'm only driving my car. But when I'm watching a Netflix movie, 100 other people, thousands, millions of other people can be watching that same movie because the experience can be shared. And the business models tend to be monopolistic. And for some of the reasons for that are like the network effect. If everybody starts converging into one particular marketplace or one particular social application, it tends to sort of monopolize it, or these platform technologies tend to be monopolistic. And you'll see this over and over again in the digital world. Capital management is another thing, and especially for our small and medium-sized businesses, whenever I talk to manufacturers, the thing that they're struggling with the most is, how do I allocate, how do I figure out where do I make my capital bets? Everything is so expensive. Capital equipment is something that's a very difficult decision to make. And so on the physical side, we're really struggling with this equipment allocation, right? We're trying to figure out how do we justify a project? And so we use traditional tools like NPV analysis, net present value. But on the digital side, it's not so much about the capital outlay, right? If I'm creating a software business, I can get all my tools off the web on a cloud platform, and my physical infrastructure is fractional in terms of value compared to my capital expenditure in a manufacturing environment. And then it's about liquidity. It's about holding on to as much cash as possible so you can make all those option-like bets. And what we mean by option-like bets are, small bets that would lead a high return. And if you look at it, if you look at the venture capital world, the venture capital world has basically has survived or thrived actually on this model. They make smaller bets, but only some of those bets then give them the 10 to 100x return that makes up for the whole portfolio. So that's the digital side of the world. Now, that's great for if you're just a digital company, but if you're a manufacturing organization and you're starting to kind of figure out how do you do this other side, how do you overlay this digital mindset, the most important thing to remember is that we need a duality mindset. We cannot have one or the other. You still got to produce the product, but you got to overlay the digital technology. And we'll look at how some companies are doing that in a bit. So the duality mindset is absolutely important. And then along with the duality mindset, there's a huge impact on the workforce. So while we talk about Industry 4.0, Industry 3.0, which was sort of the prior industrial revolution, which was really automation, has had a different sort of impact. So in 3.0, we were all about task automation, and that means we were all about how do you create tactical automation. But in Industry 4.0, that tactical automation is actually taken care of by the technology. And so really what the technology is providing to the operator or to the executives is the decision support. Industry 3.0 tends to be very process driven. Industry 4.0 is outcome driven. Industry 3.0 is about tactical load, and Industry 4.0 is about strategic load. And what we mean by tactical and strategic load is that the decisions that we're making as people in the workforce in Industry 3.0 companies are making tactical decisions. I've got to get this over there. How's the best way to get this over there? I've got to move this from here to here. In Industry 4.0, that's taken care of by technology. The question becomes, what's the customer experience when I move this from here to here? What's the availability when this happens? What's the decisions that we need to make to elevate to a higher level? And that's the transition that we're seeing right now. And we can talk a little bit about it if we have time during the Q&A. The important thing to understand and remember is that physical will always, however, be relevant if it is driven by a digital strategy. That is, all these successful companies that have kind of gone down this path of Industry 4.0 have a physical along with a digital. It's not an either or. And so with that, what we talk about at Automation Alley is this concept of the 5 principles of digital transformation. And the first one, the most important one, it's probably the one that I cannot stress more than anything else, is that every organization needs to become a software company that happens to do X, that does X. And this is the piece that sometimes can be the most daunting. And what we mean by becoming a software company is that you don't need to go ahead and start writing a bunch of code right away, though that will come later on. What you need to do is you need to embody, you need to really understand what does the software mindset feel like. And the software mindset is about being agile, thinking about the customer experience, making minimum viable solutions that then can be scaled, and really understanding the value of iteration. And some of the technological tools that are now available to us can make that happen, right? So when we talk about Industry 4.0, if you look at those 8 sectors, we'll focus on one of them where we can actually make this happen. But this is probably the most important piece of all the 5 principles. The second one is start with a customer experience and then explore what the product and service duality is going to look like. And this is also going to be different. This is also going to feel like, wait a second, we've never done this before. We make widgets, we make this, we make that. And you really almost have to look forward, look at what is the outcome, what does the outcome of that widget provide, and really try to get deeper understanding of what that customer journey is. It's a different way of looking at things, and it's like anything else. Not all of these are going to be successful. Some of these are going to feel like completely wild goose chases, but that's okay. It's the discipline of kind of doing that that's the important piece for a small business. The third one is understand the digital and physical duality. So when we're starting to engineer on the physical side, we understand how that works. It's that incremental change, it's that serial access, it's that throughput. On the digital side, it's iterative, it's agile, and those two have to come together. And we really need to understand how those mesh well together to really understand that. I'll give you an example. A few years ago, I was at an event where I met a manufacturer, and they made bolts. Actually, they made fasteners. And at some point, their customer basically asked them to put a sensor on that fastener so that they could actually measure the torque that that fastener was undergoing when it was in operation, when it was actually in the component. And they also wanted that sensor then to broadcast the measurement of the stress that it was encountering, the torque that it was encountering. That is an example of this digital physical duality, because from being just a simple bolt, that fastener became a data source. And with that comes great implications on things like who owns the data, who processes the data, do we just give up the data? Is there any filtering? Is there any cleaning that needs to be done? Is there any validation? Is there any calibration? All those questions sort of start coming up, and we have to think through what's the best way to do it. And it doesn't make sense to build this massive solution. You really have to kind of start iteratively to say, what's my first step in making this useful? What's my second step? And how do I iterate? That's the software side of the world. The physical side of the world is making sure, obviously, that the component is manufactured, that the repeatability is still there, and so on. So this is that understanding and accepting that digital and physical duality. The fourth one is what we call making bets, small bets, using an agile framework. In the traditional realm, we don't think of making small bets. Nothing is small, right? I mean, if you're making something, you're going to first acquire the equipment to make it. not talking about a situation where you might contract manufacture something, but if you're going to be making something, it's a huge capital outlay. When you start overlaying this digital mindset with some of the technologies that are now available, that changes. Now you can start making small bets using this agile framework, and that's this software mindset that we need to start bringing into the traditional mindset and bring those two worlds together. And then finally integrate the physical and digital engineering. At some point, this needs to come together. This needs to kind of get integrated into one cohesive product that then gets shipped out to the customer. So the learnings are that the way we've got to do this is we have to start with culture. It's in most cases, when we do our assessments for manufacturers, one of the programs that we have at Automation Alley, it's the culture of the organization that often stands in the way. And part of it is because change in a traditional manufacturing environment can be very expensive. And so often that change is tamped down to a minimum. But when you start talking about being iterative and being agile, change is essentially something that you need to embrace. So we have to create a culture of learning where we don't look at failure as a negative, but failure as an opportunity to learn. We need to understand how to sandbox experiments. We need to know how to create this learning that can be shared, and that learning organization can then manage disruption. That's sort of the path that we outline for our organizations to be able to address the disruption of Industry 4.0. And also in the form of critical priorities. The most critical priorities are obviously, we talked about culture. We also need to understand how do we change the financial thinking of the organization and introduce this notion of optionality. So there is, in the finance part of the organization, a learning to be had, which is we're not looking at everything that is going to have a massive return on investment, but it's also not going to have a massive investment. We need to understand how do we make small investments, small learning, and get great return on investment in the form of learning. And then finally, what we need to do is we need to understand what is that technological arc that can be aligned with the human context. What is that customer experience, and how does the technology drive that? Those are the three pieces that we look at in terms of the critical priorities. So with that, let's take a look at this case study that I want to share. Two case studies. This one is on Netflix as an organization. I'm sure everybody in the audience knows Netflix. So Netflix today is producing all kinds of movies, but when they started, they were in the DVD rentals by mail business, and this was in the 2000s, in the early 2000s. And they were really a fulfillment shop. They really knew how to very efficiently deliver DVDs by mail to customers who had put them on like a DVD queue. But from that, they graduated and they evolved into third-party streaming. They were basically streaming third-party content in the sort of the mid 2010s, if you will. And now that meant that they were a cloud services business. They had to really ramp up their cloud services capability, understand how to deliver tons and tons of video content, online streaming. Today, however, they're an original content producer. They are actually like a studio. And now they're very much into the production of original content. So how did they make these changes? That's three different business models. And interestingly, that first business model of DVD rentals is still actually something that they have. A few million customers still get their DVDs by mail from Netflix. So they've kept these two pieces, and they have now started this third business model. Well, how do they do that? They did that by being a software first company. They started off as a software company that happened to do DVD rentals. Then they happened to do third-party streaming, and now they happen to make original content. So that's an example of a company that has successfully gone through three different business models. Here's another case study that is actually much closer to home, and this is actually in the manufacturing space. So if you've heard of Relativity Space, they call themselves a software company that happens to be making 3D printers, that happens to be making rockets. Very interesting business. I would urge everybody in the audience to Google the genius of 3D printing rockets. It's a YouTube video. It's about 20 minutes, well worth the time, where the CEO, Tim Ellis, goes through this whole arc of why they are using 3D printing. And 3D printing is the one technology of all those 8 sectors that we believe manufacturers need to be looking at immediately and understanding, because that's the one technology. If there's one thing you need to focus on, and yes, there is value in all the others, this is the one that brings that digital and physical together. This is the one that's going to kind of give you the path forward for the workflow that you need to have for an Industry 4.0 ready company. But let's take a look at why they're doing this. What's the business case behind it? So in the traditional approach of making rockets, there are about 30,000 parts that have to be sourced from a huge ecosystem of suppliers. There is about a 12 to 18 month build cycle. There's about an $80 to $100 million spend per launch. That's the traditional approach. That's what we're all experiencing today. If Relativity Space is successful, and they're going to be doing a test very, very shortly, and we believe that they probably will be successful, their approach requires 300 parts. They have a 60-day build cycle, and it's going to be about a $12 million launch. When that happens, that is going to fundamentally change the aerospace industry as we know it, because that validation is going to have a massive ripple effect. It's not even going to be a ripple, it's going to be a tsunami that's going to go through the industry, because it is going to open the eyes of many traditional players. And from aerospace, it is going to go into other traditional businesses. So from our perspective, if there's one technology that all manufacturers should really, really be looking for, it's 3D printing. And it's not that hard to get into. Just a quick story. Automation Alley did a project called Project Diamond during the pandemic. We actually distributed 300 printers with the support of our county, Oakland County and Macomb County, the 2 counties that are, we are in Oakland and Macomb is the neighboring county, 300 printers. And we're now seeing many companies that have come to us and said, we would never have done 3D printing if it hadn't been for Project Diamond, and you've opened your eyes. We've had so many stories of companies understanding how this is going to change their business. So this is, I will leave you with, if there's one thing you've got to do, it's understanding how this is going to impact the business moving forward. And also specifically, in the case of Relativity Space, it's metal. It's their 3D printing metal in a very, very complex environment. And I would urge you to take a look at the that printer, the video. So with that, open it up to any questions, any comments. Back to you, Brad.
Thanks, Pavan. Yeah, excellent. Lots to cover when we talk about Industry 4.0. I know that some of the companies in our audience today are using 3D printing. I've seen it, you know, in the stamping and fabricating shops for prototypes and tooling applications, maybe for some maintenance and repair applications on the shop floor, but many are not. So what kind of advice would you offer to those companies that have never experienced or experimented with 3D printing, I guess in terms of the ROI perspective? How expensive is it to get into, for sure, polymer, but even metal, and the ROI that companies can expect, the types of applications that you've seen?
That's actually one of those things, right? So if you've never done it, and if you're not convinced, you know, buy a small printer and play with it. It's not going to produce production quality components, but it's going to start giving you ideas. It's going to start giving you some really interesting thoughts in terms of where could this go. If you have a little bit more faith in the technology, buy a production-ready printer. There are now production-ready printers that can make components that can actually go into usable parts in the, you know, less than $15,000 range. Some of them are even, you know, even less than that, right? Do your research on materials. There's so much you can do without spending a dollar, just in understanding the technology, and it's just a question of making the decision to say, I'm going to learn about this, I'm going to figure this out, and I'm going to seek out case studies that might be pertinent in my industry. I'm going to seek out use cases in my industry. So there's a lot of learning you can do before you spend a dollar, right? But it is really a question of, are you going to give it the attention? A lot of times what we see is this jaded notion and I understand that, because a lot of times when you're in the traditional business, you've been told something is going to change your life forever, and it doesn't, and all you ended up doing was spend a whole bunch of money. I completely understand that, right? And so what we say is, don't spend any money, just get your education, just learn, right? Automation Alley, we are a nonprofit, we're a resource. Get signed up, on our newsletters. We send the stuff out all the time. Our role is to essentially, we're Michigan focused, but at the end of the day, Michigan can't succeed unless the whole United States succeeds, right? So we're very much about this bringing back manufacturing. So, please connect with us, right? automationalley.com and just learn. I would say just learn, right? And then when you start feeling like you have the feeling like you want to spend a little bit of money, spend a little bit of money, right? It's not going to break the bank. Start talking to customers. There's so many things you can do. A lot of times I think we feel like it's so new, but there's always a little first step you can make. And don't ever worry that your first step compares to somebody else, right? It's your path, it's your journey. Just do it.
Right, sounds good. I liked early on in your presentation, you talked about the need to think more like a software company and be more agile. And we talked a little bit yesterday in our sessions about the role, the increasing and evolving role that IT now is playing in manufacturing companies. So it's affecting the shop floor. It's not just guys, looking at computers and software and making sure everything's running right, but actually being involved in production flow. I know there's a lot of challenges with the Industry 4.0 transformation. Talk about, from your perspective, the challenge of making IT more involved in manufacturing and some of the other challenges that you see in the foundation that's challenges that companies have to make.
Yeah, thank you. That's if there's one thing that holds companies back, it's a little bit of this inertia, right? The thing we see all the time, the dynamic we see all the time is they've never been part of the space, manufacturing space. I don't quite see how it fits. And so it's really it's a cultural blind spot more than anything else. But you can create situations that actually then change. I'll give you an example. So we talked a little bit about Project Diamond. Project Diamond, Diamond stands for Distributed Independent Agile Manufacturing on Demand. It's a project where we gave out 300 printers in Oakland and Macomb counties. Those are the two counties. Oakland is our home, Macomb County is our neighboring county. And we gave them to companies who basically put their hand up and said, you know what, we'll make PPE if you ask us to, because it came out of that need where we needed PPE, but we said use this printer as if it were your own. And many companies who had even seen 3D printing 5-10 years ago that was not really up to snuff in terms of production capability, got this production capable printer courtesy of the grant, and they started that thinking like a software business. We met a company when the owner said, let's just print some labels. So these are labels that go on their machine. They saw that these labels were good quality. They said, well, maybe we can build this little housing. Well, maybe we can do this, and maybe we can do that, and maybe we can do that. And what's interesting is now the innovation requests and ideas are coming from the people on the front lines. The people that we traditionally think of as, oh, they're not sophisticated, they don't understand digital technology, they're giving us the ideas. Why? Because the ideas are in 3D. The ideas are about how these components fit together and work together, and these guys understand how it works. And they are now working with the engineers who are saying, okay, well, let me then model it this way, and then let me put this particular support structure, let me put fiber over here and make it strong enough for the application that you want. And they're just printing one, testing it out, and maybe the first one gets scrapped, but the learning results in the next one and the next one. And that's that agile iterative design, agile iterative thinking. That's why we keep saying, you know, if there's one thing you want to do is just bring this into your shop and let your people play with it, because all the other stuff, the AI, big data, IIoT, and all this stuff, which is super critical, right? That becomes less daunting when people start thinking digitally. It's almost like you have to give them the tools to start saying, let's just try this. We don't need to build 500 of them. We need to build one. We'll test it out. Then we'll kind of iterate, right? That's basically what we're talking about. We actually have one company that's converted one of their traditionally manufactured products into a SKU. Then they found that they could sell it, right? It's a 3D printed on-demand SKU. They hold no inventory. They found that they could make a small little change and create another SKU. So now they have two SKUs. They're both sellable. They've gone to like 15 of these things, and they sell all 15 and hold none in inventory. They're just 15 digital designs that they print on demand. Now that's an extreme example, but what if you could do something like that, right? That's that thinking. And what I've seen in our smaller and mid-sized manufacturing base, you just got to give them that initial kind of, here's what the lay of the land looks like, and then get out of the way, right? Because they're super innovative. They'll figure out where to go from there. You know, we don't need to hold their hand along the way. They're, you know, they've basically survived, you know, at least those that are still in business have survived, you know, very, very difficult business environment. They're very, they're capable of survival. Sometimes they just need to know what's capable, what's possible, and then, you know, it'll open up a brand new world.
Right. Well, and that's certainly the kind of technology that is going to appeal to, you know, the next generation manufacturing workforce that we all refer to, right?
Yes.
It's going to engage them in your company and help them be more innovative. And yeah, it's interesting. Very good. Okay, Pavan, thank you so much for that presentation and for joining us today. I hope everybody learned a lot from that. Again, thanks for joining us.
Thank you so much.
Next, we are going to welcome for our next presentation, Gary Minchell. Gary is the founder of the Manufacturing Connection, and he's going to discuss with us today laying the groundwork for IoT success. I think what Gary's going to talk about is going to build nicely on what we just listened to, and really talk about how to build not only Industry 4.0 and IoT projects, but also building the right team. Gary is a passionate communicator and an advisor to industry on a variety of topics, including technology trends and vision, marketing, and leadership coaching. Throughout his business career, Gary's held leadership positions in numerous areas of manufacturing, including IT, product development, and marketing. So please welcome Gary Minchell.
Hi, thanks, Brad. Appreciate being here. Great presentation by Pavan. Recently, I've been flooded with press releases from 3D printer companies, and it's amazing where that technology is going these days. But as a friend of mine just wrote to me, when the 3D printer starts printing its own replacements and new 3D printers, maybe it'll be time to watch out. I don't know. But anyway, my take is going to be a little bit different. I'm an Internet of Things person, almost by accident, just kind of like my manufacturing career. I took a part-time job out of graduate school in manufacturing and stayed for 25 years before I became an editor. And at that point, I started writing and thinking and communicating with a lot of people. And it's been a very interesting time. And I know y'all are in various aspects of manufacturing. I'm going to take a slightly different thing because I figured you've heard a lot of success stories about your own sort of industries or technologies. I want to look at Internet of Things. I'm also going to talk about disruption and a little bit more about organization, more on the plant level, which is my life. So let's start out. You will be disrupted sometime. And we can look at market trends. So there was a market problem in the mid 19th century in America, and that problem was that the initial European population was on the East Coast, and you'll probably know that in 1848 gold was discovered in California, the 49ers, and all of a sudden we have a big population on the West Coast, big population on the East Coast. They wanted to communicate with each other. If you sent a letter, it would take a long time. Therefore, some bright young entrepreneurial people, yes, they existed in 1860, they looked at the situation and said, let's try a different approach to getting mail across the continent. So it was on April 3rd, 1860, the Central Overland California and Pikes Peak Express Company, called the Pony Express, you may have heard of, began operation. It revolutionized movement of information by transporting letters from St. Joseph, Missouri to Sacramento, California, roughly 1,500 miles in only 10 days. On October 21st, 1861, the Western Union Company spliced its eastern and western wires together and thus created the first transcontinental telegraph network. Just 3 days later, less than 19 months in service, the Pony Express went out of business. You can be disrupted more quickly than you may think, partly technology that you need to watch out for, as Pavan just explained, and partly just a business process or business solutions. Data communications continue to accelerate and displace companies fixated on the last technology. The world of smart manufacturing, Industry 4.0, digital transformation, digital twins, digital thread, we have all those terms and so forth, is causing headaches for executives whose boards are reading about this stuff and saying, why aren't we doing this? And they say, well, how are we going to proceed? Businesses are still being distracted by digital technology. And I was thinking of a couple of different disruptions. Think of taxis. I use Lyft and Uber a lot of times when I'm traveling, which I'm doing again. And hotels disrupted by Airbnb. These were digital disruptions, meaning it was easier for the customer to connect with the supplier, which is always a good thing. So as the boards get together and they discuss things, how many of you have been in these discussions where, why don't we just don't change at all and something magical happens? I had a boss one time. He came to me. It was the first marketing manager job I ever had. It was in computer electronics. And he said, Gary, I don't understand. Steve Jobs, Steve Wozniak, millionaires overnight with their Apple II computer. And here we are trying to sell this board, and we're not making all that much money. And I said, it doesn't really happen that way. It has to meet a customer need, and we have to get it out there. And in technology, we always have to be new. But we discovered that some people think technology, like my boss, is the magic that will just happen. But it doesn't work that way. It's not always about technology. We develop technology to solve problems. In our case, business problems. We all need to contribute to the success of our organization if we want to keep our jobs. I know, been there, done that. My first software job, a long time ago, I hate to date myself, but it was in the late 1970s. I was doing an MES project for a manufacturing company, and I really was just trying to solve an essential problem, and it was basically twofold. One was better organization of the bill of materials. I put the bill of materials on a computer, and then we put the latest costs of the materials in there. The business problem was a better way to calculate the cost of material for our product, which at that time was Airstream trailers. And what we were trying to do was that was used by the accounting department, and it impacted so many financial things, but it all started in engineering where I worked with the correct bill of materials. I went to, I called it back then IBM school. I went off and my first computer training, and basically everything I learned in 1977 about this 1978 project is still true today. It begins with good data. If we don't have good data, we're out of luck. It continues with understanding the process that we're trying to do. First, we define the process, then we add software. Don't do it the other way around. We needed a robust and verifiable change process, and we needed to get reports to the clients in a timely manner. These were still true today. I learned all this 42 years ago or something like that. I'm older than I think I am. But so before we jump into anything else, we need to think about this board table that you see in front of us. What if around that table, instead of a bunch of similar looking people with dour faces, what if we had a diversity of people of different ages, different maybe ethnicities, different disciplines, engineering, maintenance, production, marketing, sales, clerical, whatever, a mix of people, a mix of genders. And have you ever been in a group like that? When we get a diversity of opinion, we get around a table and we start getting a lot of ideas, and we start coming up with more innovative, different ways to solve our problems. Maybe we hear about problems we didn't even know existed until somebody brings it up and says, did you know that down in operation 25, and so on. So that's the first direction I want to take is getting all these people together. Now, this is a control room. It's just a stock photo I got from a company, and maybe not in your industry, but my goodness, there are jobs I've had that I wish I had this sort of thing where we had a nice space for diverse people from, in this case, there was production, operations, engineering, maintenance, reliability, different kinds of people, all those screens on the wall. They could see data from this process, this machine. In this case, maybe the weather. If you've got an outside operation, when a weather front's coming through, gets to be pretty important. I could see remote stuff. Maybe I've got a remote operation somewhere, or I have a somebody in my supply chain who's making stuff, and I need to see what they're doing when I'm going to get it. Have you ever been hung out there waiting for material to come in? I have. It's not fun. I know that. So this is a case of we can bring some technology in, and using Internet of Things, because eventually I want to talk more about Internet of Things and bringing people together. And we can bring all this data into a central place, bring people in to collaborate. We can solve business problems. So I said I want to talk about the Internet of Things, and a lot of people get confused about Internet of Things, just like Industry 4.0. I think I was in Germany when the Germans came out with that phrase, Industry 4.0, and then it gets defined and redefined. Internet of Things, I like to say that the Internet of Things isn't a thing, and maybe not even the Internet. It's really just connecting digital things together. And the idea is I'm going to find data from whatever data source. I'm going to move it to some place that needs that data. And so that becomes the Internet of Things. A lot of things you need to think about when you're looking at an Internet of Things installation, process, program, whatever you are trying to do. One thing is you'll hear all these buzzwords, and so there's edge devices, smart sensors, cloud, and various IT kinds of topics, but they don't have to be that exotic and esoteric. Probably an engineer has a server. I remember an engineer 20-some years ago at Hershey who had a server in his office to connect all the manufacturing data in. He was an early precursor to this Internet of Things. And so servers, just collect all the data and have a compute power. Cloud is taking that server and putting it somewhere, and it may be in the closet, and it may be Amazon Web Services, Microsoft Azure, Google Cloud is now in the act, Oracle is in the act. Everybody, there was a famous comedian from vaudeville days who said everybody wants to get into the act, and there are a lot of ways you can go to get into the cloud, which is a good place to store data. But sometimes the bandwidth of moving from the factory to the cloud is too much, and so we have what's called the edge, which is basically a computer connected to all the sensors. It's got some software in it to do database analytics and so on, and then it can filter and just send to the cloud the things that need to be stored for further analysis and historical reasons before that. These are all different parts of the Internet of Things. And another important technology, and I sort of forgot about it in my presentation until yesterday, I was watching a Qualcomm industry event, and networking. Do not fail to keep up with the latest networking. You may have heard of 5G. Some people thought that 5G was just going to be, a faster thing on my phone to get me data faster, for example, over a cellular network. 5G has a lot of potential power. A private cellular network in your factory, if you have a very big factory, that could really work well. Qualcomm was talking about 5G as the last mile of broadband. Instead of running, your supplier runs a fiber cable to your home office or your plant or whatever. Instead of that, 5G coming up where it could be wireless fiber coming to your place of business, to your internet connection near you. Wi-Fi. So sometimes we go from broadband to Wi-Fi. I've got a whole broadband to Wi-Fi set up right behind my computer screen here. And Wi-Fi 6 is going to be really, really powerful for increased security and so on. So Internet of Things, data, that's all really cool stuff. So the question is why? Why are we collecting all of this stuff? I talked about digital disruption and Internet of Things. My guru when I became a quality assurance manager a long time ago was W. Edwards Deming. And he says the ultimate purpose of for collecting all this data is to provide information for action or recommendations. And we need to remember this sort of thing. There's got to be an action after our collection of data. How many places, maybe in your factory right now or something, how much data is sitting around that's not even being used? Marketing doesn't look at returns data. Maybe you got a problem customer or a problem with a customer, something like that. Maybe the quality people aren't looking at some of the curves that are coming off of a machine, or they're not evaluating the reason for the returns that you're getting. And there's data sitting there, maybe they're not even looking at it. Maybe production isn't watching the trend curves off of a particular piece of equipment and don't notice that the die is wearing out. Maybe the maintenance people aren't watching the curves coming off the vibration sensor on a motor, don't realize a bearing is about to go out, and then can fix it before it breaks and causing unplanned downtime, which is a bad thing. Sometimes management doesn't look at some of the data that comes in and misses the fact that maybe overtime is creeping up, and there must be a reason why we're having to work more hours to get the same product out. Whatever. A lot of data, and we talk about building, things with intelligent sensors and so on. But if we're not using all that, what good does it do? So have a purpose and work on it. I had to put this in. I ran across this cartoon because I get a lot of these kind of press releases. We just have to amplify digital, experiential, transformational, social influencer engagement if we want to wait, what do we do again? That some people look at digital transformation and think it's some sort of a big word like that. It's not really a buzzword. It just means we're using digital technologies and digital data and information in order to solve big business problems. That's what it's all about. It's real. It's a real thing. However, I was just at Automation Fair in Houston last week, and a friend of mine went to a session put on by 2 end users talking about digital transformation. And so he went up to him, because my friend's a cynic, and he says, "Can you give me just one example of some digital transformation that you're doing, that you were just talking about doing digital transformation?" One guy looked at him and said, "Well, I put an Ethernet switch in last month." So obviously putting an Ethernet switch in isn't digital transformation. Digital transformation would be all that data flowing through that Ethernet switch that somebody's using. I'm collecting it, I'm using it, I solved a problem somewhere along the line. And it's old too. I guess once upon a time I had a role with a company that designed and built assembly machines, automated assembly machines. We did a project in 1985 where we took parts in, we read what the part lot was, did some stuff, and we read what the part lot was going out so that it could be traced. It was stored in an early version of an IBM industrialized PC, had a database. We communicated even back in 1985 to the corporate manufacturing database, or at least in the plant. This was all digital stuff that they did to track parts for warranty and production purposes and a number of things. And that was a long time ago. We've been doing this. We just haven't realized what we've been doing as much as we could be. Kind of going into a little geeky stuff here. I'm a controls person. So we had something called the Enterprise Control Pyramid. Nothing like Maslow's pyramid, thank goodness. But the people in the room when this was invented didn't think that it was going to last as long as it has. All I wanted to show here was, in a past life in controls, automation, digital software, people visualized data flowing pretty much one way. We had like the physical layer, the I/O, discrete process batch stuff, and data was there, and it flowed up to the control level, and then to some sort of a SCADA level, and to an MES level, and so on. And that was the paradigm for a long time. But this is a model. Don't bother trying to look at the whole model, but I picked it up from MESA, the Manufacturing Enterprise Solutions Association. This is their older model. They replaced it now. But what I wanted to show here was there's a whole lot of data sources, you might call them servers, and a whole bunch of things that use the data, and data just flows. I've got a sensor here. It doesn't need to go to the control system. It needs to go to the ERP system, but the ERP system needs to look at this, and maybe it flows to the MES system. In other words, it can be fairly complicated to draw lines of everybody that needs data somewhere, and it's a good thing. I'm only going to use the data that I need. I can get it directly from the source. It's going to be useful immediately. I could store it if I need to where I needed it, and so on. So this, I call it Internet of Things equals connecting things equals a data explosion, which is why we need servers and maybe buying a big chunk on AWS, remote cloud servers, because we're going to store it, but we're going to store it because we can use it. So I want to tell a story. This is a refinery story, but don't worry about it. It is applicable. It's just one of the best Internet of Things case studies that I run across. But the story includes a party van, coyotes, insurance companies, IT department. Oh, and it's about refining, flammable materials, and safety. And I went to an enterprise computing and IT company user event, and it seemed like a strange place to be the moderator of a session called the Refinery of the Future. What in the world were they doing at an IT event? But anyway, we were talking about this, and the company's name is Texmark Chemicals. They make a product, and I'll try to pronounce it. I'm not a chemical engineer, but their product is dicyclopentadiene, and the stuff used to make it is flammable. Safety. So anyway, they consulted a company in the IT industry that I happen to do a little work with called Hewlett Packard Enterprise, or HPE, and we talked about this in a conference in Madrid, Spain, a few years ago. And telling the story, Texmark had some problems, and they teamed up with HPE and a division of theirs called Aruba that makes wireless hotspots, and trying to solve their problem. And they called it the Refinery of the Future project, and featuring advanced industrial Internet of Things capabilities. The results that they came out of this with were better process analytics, increased uptime, uninterrupted productivity, satisfied customers, and a safer workers. If I just took the refinery part out of it, it applies to every one of you, right? So every IoT implementation I've seen so far relied on predictive maintenance as the justifying application for Internet of Things. Here, the first priority was safety. They came, then was predictive maintenance, then improved operations, and consistent quality, all business problem solution situations. Texmark well, I told you, it produces dicyclopentadiene, DCPD, and the process involves a lot of flammable stuff and a lot of complexity in the supply chain, and this was even before today's problem with the supply chain. Texmark had to ensure that its workers adhered to process safety management procedures at all times, and the facility is managed in ways that put worker and community safety first. As a contract manufacturer, Texmark has to be prepared to adapt to customer requirements, which can change with little advance notice. I'm sure you've witnessed that. And it must continually drive plant efficiency and productivity. And historically, Texmark has depended on physical inspections of process equipment to ensure all systems remain working order. However, sending people to walk around all over the plant is time-consuming, labor-intensive, and often a problem. They have 130 pumps, and this is a small refinery. I've been there. You can walk the whole thing very quickly, actually. But they have 130 pumps, nearly 1,000 hours a year spent on walk-arounds to check those pumps out. Depending solely on physical inspections also carries risk because it relies on employees who can tell if a pump is working or starting to go bad or whatever. But if that employee is off sick or leaves or retires or whatever, how do you replace all of that? So the added Internet of Things, sensors and systems to do that work. So they launched a multi-phase system and to put this whole thing in order. So how did they do this? They ran across a salesperson from Hewlett Packard Enterprise who said, oh, we can do this and this and this. And they said, oh, really? Can we see a demo? They said, sure, we have a demo in our Houston office just down the road a little ways. So Texmark rented they called it a party bus, put 15 employees out of the plant of all various different kinds of disciplines from within the plant. And they drove down to the Hewlett Packard Enterprise thing to look at this demo. And they were surprised to see a Flowserve motor and National Instruments instrumentation and Wi-Fi hotspots and software from PTC and other people. It was really an eye-opening experience. Linda Salinas, the plant manager, told me that on the way to that thing on the party bus, they talked about this is Texas. They talked about football. On the way back, after seeing the demo and all the ways that they could sense everything and so on, they spent the entire trip back to the plant brainstorming ideas for fixing things. The party bus. Oh, the Coyote part. So the Coyote part is that one of the sensors that they installed when they did the whole thing was a vision system, just a camera, because they had to bring railroad cars in for unloading or loading or whatever. And when they did that, they had to open the gates to the fencing because the whole thing is fenced in. And they're out in kind of the wilds, and occasionally a wandering coyote could get in, and they really didn't want coyotes wandering around within the plant. So they had a vision system hooked up to their Internet of Things system that looked for anomalies, and if they saw an anomaly, kind of like a coyote, they could go take action. I don't think they ever told me what action they took when they did that, but at any rate, I'm sure it was somewhat drastic. Anyway, that's another safety thing. I don't want to wander around and see a coyote when I'm face to face in a refinery, that's for sure. So I want to talk a little bit about platforms in the sense that the whole system that they put together at Texmark had 12 partners. So they brought 15 people from the plant. They actually used more. They collaborated across everything, but they collaborated with a whole lot of vendor partners also. This is an example platform. It actually comes from EdgeX Foundry, which is open source. But the idea of the drawing, and once again, it's a busy drawing. I don't mean for you to look at it other than it's just an example of putting things together such that you can combine and collaborate people, companies, technologies all together. A friend of mine says platforms, tools, and ecosystems are exploding right now. And I wanted to end on a planning note. Like I had a dozen slides I could have put in. This one is purported to be from Albert Einstein. If I had 60 minutes to solve a problem, I'd spend 55 minutes defining it, 5 minutes solving it. And there's a lot of truth to that sort of thing. We tend to just jump in, say, let's solve the problem. And as the spice of technology, some salesman came in, and I used to be one, so you can blame me too. But some salesman come in, hey, I got the latest variable frequency drive or DC drive for your lathe or whatever it might be, and you say, oh, sounds good, I'll buy you 2. And if the salesman is happy, but that's maybe not what you really needed. Maybe you needed to spend more time thinking about the whole thing, bringing in all these people, this collaboration idea, like the roundtable I talked about, bringing in people from different disciplines. I've been in company after company after company out on the factory floor where I see them gather together from different disciplines, and they pick a topic and they explore, they get data, they refine the data, look for problems, and take off, and they then solve individual problems at a time. If I'm leaving with something based on this idea of collaboration, planning, the data comes from the Internet of Things, and that's very, very important because we learned in lean manufacturing, you need data to be able to actually figure out how you're going to solve the problem. If you don't have data, you don't really know what the problem is. But you need to plan all this stuff out, bring people together, and allow them the freedom to actually think about and define and brainstorm ways to solve the problem. Then bring in technology people to say, hey, do you have a technology that'll help us, put in, maybe you only need 2 sensors and some really simple software right now and 1 computer. And then you can start with that, have a success. And then people say, oh, maybe it helps. And then you can get more people on board. This is change. People don't like change necessarily. And so you have to build on success and build on success. So anyway, I think I have come about to the end of my time. And Brad, I can send it back to you if you wish, and see if anybody has any questions.
Excellent. Thanks, Gary. Yep. If anybody has any questions for Gary, we certainly covered a kind of soup to nuts overview of IoT and Industry 4.0. Go ahead and use that question panel to to write your questions, and I'll read them to Gary if you've got any. One of the things we haven't talked about much, Gary, this week so far is the whole security issue. And with your background in controls and technology, I think a lot of folks are at least looking at, if not concerned with, data security as the stuff is, flowing through a network as more and more data is kind of moving around the internet, so to speak. What's your perspective, especially for small to mid-sized companies who might be concerned with security of their data?
Oh, and yes, we all read the papers. We know we should be concerned. I had a customer once who said, I am never going to run a wire from one of my controllers. Well, guess what? They all do now. But so a couple of things. There are people who know security, and you don't have to hire one full-time necessarily, but you do need to build a system with security in mind. And don't think just because you don't think that there's a connection to the internet outside of your plant, there are ways people can get in. And sometimes it's an internal person or a contractor. Contractor comes in and sticks a USB drive or something and winds up downloading something. So that's part of the thing. Just talking with people who provide cloud, and actually this was several different people. If you're in a cloud service like Microsoft Azure, and I'm not selling any of these, I don't make money off any of them, but or Amazon Web Services, these people are already building in because they know they're a target. So they're already building security at that level. But good policies and procedures, watching contractors coming in, and good policies about can anybody get in and change anything or stick a USB thumb drive. I think they still exist. I don't use them anymore, but anyway, you really, really need to, is once you start connecting things, people could be hanging on outside your plant and trying to tap into the Wi-Fi. It's weird,
right.
But most things seem to be internal. So have your internal policies and procedures in place. Very important.
Okay. I thought your using safety as an example of IoT application was unique. I agree with you. You hear certainly more about predictive maintenance, and we talked yesterday about equipment OEE applications. Have you seen other applications where safety was maybe a primary goal of IoT, or was that somewhat unique in your experience?
This is the best one I've come up with, and because of the type of process. So I was trying to think about all the customers I've had in metal forming, and where you could put some sensors on a safety sort of thing. Unfortunately, back in the day when I was really out in those plants, people did things like taking or opening the doors off of the control cabinets and exposing everybody to 600 volts or whatever, stuff like that. I think people are much more safe these days, but a lot of stuff around robots and personal stuff. You put a tag on a person could be data. And I worked in manufacturing. I was as cynical as everybody else, like, oh, are they tracking us to see how much we're going to the bathroom? But putting a tag on somebody, if there's an incident and knowing that there are 20 people in that department over there is really valuable if you're going to send in an emergency squad or something. So there are a number of those kind of things outside of the equipment or the asset, but more like your human asset, like protecting them, gets to be very interesting.
Yeah, we even heard a little bit about tagging people. Sounds unusual, but through the pandemic, right? For keeping track of who's been exposed.
Oh, that's true. I talked to a division president of a large company, and they had done software such that they could determine if somebody got this. Yeah, this is back in the beginning days of the pandemic. I don't think we're as worried as maybe we should be, but yeah, to tell if somebody got within 6 feet of somebody else, could check people coming into the plant and going out of the plant and so on. And that was useful. Just to keep things from spreading. So
yeah, but I wonder if the companies who who implemented that technology based on the pandemic. Now we're finding other applications for it, as you mentioned, to track movement. I don't know the answer to that, but it'd be
interesting. I don't either. Thank you for the idea. I'll have to follow up on
that. Okay. In terms of forming a team, and we talk about we talked about it yesterday, and we talked about the previous IoT conferences, the crawl, walk, run philosophy of getting started small, find a project where you can almost be guaranteed of success to get the momentum going with IoT. Building that team, and you talked about it from cross disciplines. What's the kind of optimum size of that team? Are we talking 5 to 7 people based on your experience, or is it more because you want to get more disciplines involved? What's the secret recipe, if you will?
Well, I don't know if there's a secret recipe, but I think a rule of thumb is a small group larger than 12 gets to be unwieldy. Probably 5 to 7 is nice. If you're picking somebody, I was at a roundtable put on by an IT company, and they brought in some customers talking about IoT. And this is fairly early on in this whole IoT discussion. And one person said, well, the president of the company came to me and said, you head up the IoT thing. Oh, everybody said, what are you doing? What are you doing? Because nobody knew. And it's kind of like pick a champion, somebody who's organized but passionate about improving and doing this sort of stuff. And then a lot of times you'll get a core group and bring in ad hoc people. So you learn that, oh, I need to know something about this other department. Let's bring somebody in. They can help us out on an ad hoc basis and send them back out. So if you get 5 to 7 core people for that perhaps area, and then bring in experts, bring in the engineer who doesn't have to be there all the time, but can come in to help solve this problem. Or the IT person can't be in every, because if you're a small to medium-sized business, you probably only have one IT person. So they can't be on every committee, but certainly they need to come in to help if you need a database or connectivity, security, whatever it might be. So yeah, I would go with that kind of idea. It seems to work.
Okay. Yeah, I've certainly heard that you need to engage IT from the very beginning. You don't want to come in at the end and say, we decided that we need to do this and that. We need your support. You need to get IT involved right away.
I think we're getting over the idea that IT is the enemy on the operations side. It seems to be getting much better. And I've seen some really smart plant managers who did things like moved offices around so that the IT manager for the plant and the engineering manager for the plant had offices next to each other, so they had to see each other every day regardless. I thought, that's a stroke of genius. I like that idea.
Yeah. I like that too. Very good. All right, excellent, Gary. We don't have any more questions for you, so again, thank you so much for your time. Really appreciate it. So that concludes this morning's session, part 3, if you will, of what is a 5-part series of webinars. We hope you found it so far to be valuable. And again, I want to remind everybody that an archive of the program will be available on our website along with the presentations in the PDF form. Then you'll be able to review them again and maybe share it with others in your company. So please join us this afternoon for part 4, where we're going to get into more of the nuts and bolts of applying IoT on the press room floor. We've got a presentation on state-of-the-art sensor technology for automation and IoT, and then a case study describing how a metal stamper is leveraging IoT technology to eliminate scrap issues and related unplanned overtime and downtime. So again, thanks, Gary. Thanks all of you for attending. We'll see you back here at 2 o'clock Eastern sharp. You can close your browsers now, and we'll see you in a few hours. Thanks. Okay, good afternoon. Welcome to Metal Forming Magazine and PMA's, what is our 5th annual Internet of Things experience for manufacturers. Welcome back if you've joined us for previous sessions yesterday or this morning. I'm Brad Kuban. I'm the editorial director of Metal Forming Magazine and PMA, and I am pleased to serve as your moderator today. And again, we'll do this tomorrow morning as well. As mentioned earlier in our sessions, This webinar and all the others are being recorded for archiving, and the recorded webinars will be posted to our website at the conclusion of the event. That'll be, we'll probably get those posted on Friday or maybe early next week. And we'll let you know via email when the recorded webinars are available for viewing online. We'll also have the presentation saved as PDFs for you as well. All participants in the meeting are in listen-only mode. That means that the speaker and other attendees cannot hear any audio from your site during the program, but you can communicate with us by submitting any questions or comments you have using the question box located on the right-hand control panel. Simply type your question and use the pull-down menu to pull down to Organizer. And then you'll use that same question panel to ask any question that you have of our speakers at the end of their presentation. Lastly, before we get started, I definitely want to thank our event sponsors, Komatsu and Unis. Without their support, we wouldn't be able to bring events like this one to you. So much thanks to Komatsu and Unis. All right, so now it's time to begin this afternoon's webinar session. And we start with a talk on recent improvements in sensor technology, and specifically how IO-Link has become a critical component regarding the setup and collection of machine data. Our speaker is Helge Hornes. Helge is the technology director at Pepperell Fuchs, where he focuses on expanding the use of IIoT methods in factory automation to simplify automation tasks and enhance system uptime. Dr. Hornes has published several articles in peer-reviewed publications and industry trade publications, including Metal Forming Magazine, on a range of topics such as safety networking, RFID, and Industry 4.0. So please welcome Helge.
Thank you very much, Brad. I guess you can hear me okay?
Yep, sounds good.
Great, thanks. So we'll start. Thanks for having me for this exciting event. I'm going to cover a part of Industry 4.0 that is really at the component level, and then I want to demonstrate and show how this information can be used in other types of scenarios for the improvement of control, configuration, and ultimately that leads into what needed to be done at the sensor level to make all this possible. I was trying to utilize, let me see if I can pull the next one up. Yeah, try to utilize my video. That didn't work, so I quickly put up a screenshot there. That's what I look like, pretty much the same today. And here's our agenda. So I want to review communication from two angles: the flat IP networks in regards to the RAMI 4.0 model, and also how communication is thought of today. We then talk about control and configuration of hardware. And at the end, then I will provide a number of examples of what sensor advancements have been brought to the market and how they will allow better machine utilization via predictive maintenance. So first topic, Industry 4.0 and the reference architecture model for I4O. Most everybody that deals with control systems thinks about data and where data comes from and layers of communication in this pyramid-shaped model. We have field devices, control devices, and so on and so forth, ultimately ending up at an ERP level. This is highly hierarchical, and every layer has its specific reason for being there. So field devices, that is, for instance, where one would identify the presence of a part. And then the control devices, PLCs, for instance, they will take in that information and make decisions. Should I activate the press when all the inputs are okay? The PLC will then consolidate information and move it from SCADA to MES, maybe even up to ERP, where financial decisions are being made. How am I doing in terms of parts utilization? What have I produced? How much waste did I have? And so forth. So this is the model we've all been used to. And if I break this down to a couple of examples, specifically Think about an RFID tag being utilized on a die set. And so if at the field level, we identify this asset by some asset number that's part of the RFID system, we can move this information through from the PLC to SCADA to MES and therefore determine the utilization. Now, the goal really is to be able to determine when maintenance is most advantageously handled before something breaks down, before something goes out of alignment. Another example is vibration sensing. So vibration sensors, they can provide information according to this ISO standard I'm listing there. And on the right side, you see a table that essentially tries to classify what type of machine will run well, not so well, or actually goes into damage mode at what levels of vibration. So we can configure the system, determine what the vibration values are, and pass them through the system. The goal again is to replace, let's say, a bearing or a belt in time for this machine not to even run into downtime. And then ultimately at the ERP system, when this information is available, reorder the parts so that we're never going to run out of this bearing, or we're never going to run out of the belt that's needed to keep it running well. So information is passed up and down this pyramid. In the RAMI model, the world is a little bit more complex, or I would rather say a little richer, in that we still find this pyramid structure along one axis. These are all the layers of the pyramid. But what is very different is that we don't have to bring data from one to the next, not from the field device to the control device to stations to work centers and so forth. Communication can now occur essentially in the up direction between any two participants in the setup. And this is extremely useful because it makes data flow so much simpler. I do not have to bother the PLC to take in data from the field and send it up. I can have the field device make information available, and anybody else that needs to have it at any point in time can directly communicate with this field device. So this is what is considered a flat IP network. Everything puts information out there for everybody else to use it at the right moment in time. Another new aspect of this model is that we are considering now the lifetime of an asset from the development into the full utilization part. And I will today focus on the second, the phase when a product is an instance. It's no longer just a catalog item. It's a specific sensor. It is a specific PLC. It could be a specific cable. And what I'd like you to see today is something that was worked on over the last few years. We call it the digital nameplate. This is an international effort to give every piece of equipment a unique identity and allow the owner, the user, to retrieve information about the unique parts that's being used. And I'll show you in some detail where this goes. Now, if you have a cell phone, get it ready, because you can actually participate in this by retrieving information live about a certain item that I'll show you. So having said that, how does flat IP network or IP networks and controlling configuration come together? If we go back into the past, maybe, I don't know, 15, 20 years ago, this is what systems typically look like, and to a large degree they still do today. You have a number of I/O devices, sensors, actuators that are connected to the PLC, and the PLC is somehow connected to the MES. So it receives information about what needs to happen at the field level, and it then performs operations based on these input devices. What happens in this world, or at this stage, is that the logic is running on the PLC, it takes in inputs, and it sets outputs. And at that point in time in the past, all the configurations of these sensors and these actuators, they were fixed. And I had to actually dig quite deep into an image database to find a product that was that rigid. We had one. This is an RFID controller, and you can see the dip switches. Anything you ever wanted to do with this device required you to configure it ahead of time, put it in operation. You could then instruct it to read or write tags, of course, but flexibility was extremely limited. You decided the mode of operation, what type of a tag was coming, what type of head was used ahead of time, dip switch configuration. Now, more recently then, some smart people thought that's really not a good way to dealing with hardware. It would be much better if the PLC had the ability to change configurations of hardware on the fly. And that allows us to automate, highly automate replacement procedures. So one product gets replaced, and the person that does the replacement no longer has to really do anything with it. Put it in operation, and the PLC identifies, okay, something new showed up, and it downloads the parameters. The rest of the operation, the logic, the I/O consumption, setting of outputs is exactly the same. And most of you have, of course, heard of IO-Link. IO-Link is a low-level point-to-point communication scheme between controllers and sensing products. And sensors can be, just as the word implies, sensors, photoelectric, inductive, capacitive, but could also be RFID systems, can be stack lights. All of these kinds of products can be configured by the PLC to do whatever needs to be done. So here's an example. I'm showing you there an ultrasonic sensor, and this ultrasonic sensor, did I lose my connection? Brian, can you still hear me?
I can hear you, but I cannot see your presentation.
Okay, well then, wow, that was weird. I have no idea what happened. I gotta.
You're on the phone, right?
No, I'm going through the audio connection. So let me, hopefully this picks up where it left off. Okay, I'm sharing again. Now, would you?
Yep, you're back.
Oh, all right, I'm glad it happened. So these are two ultrasonic sensors, and what can happen here is that via PLC command, via PLC control, the beam pattern, the beam width of this product can be changed on the fly between every single product if necessary. It's very easy, go wide, go narrow. So this allows us to focus the ultrasonic beam to match the product we're producing, and therefore we can have various products running over the same line. They could be quite different, and the sensing technology can be adapted to the needs of this production step. Another example, already mentioned vibration sensors. So vibration sensors will measure, for instance, the speed, the VRMS value of the machine, the vibration spectrum, and it's possible to set trigger alarms. Similarly, via this IO-Link methodology, we can change the allowed or the accepted level where this alarm will trigger. So we can make this dependent on certain functional aspects of the system. Another one very common is changing the sensing range of a photoelectric sensor on the fly, changing it between near range, could be 0.5 meter, to far range, 1 meter or 2 meters, whatever the technology allows. And then lastly, my last example shows a rotary encoder where the pulse rate can be configured via PLC control. So sometimes it may be useful to have very short pulses. In other cases, it may be useful to have much longer pulses between so many pulses per revolution. So this flexibility comes with these IO-Link sensors. And if we then go to the next picture, and this is kind of the now and today state, we're going to expand this even further. And the difference now is that we're separating control that runs on the PLC just as before from configuration and ingestion of feedback information. So we're utilizing IoT technologies, OPC-UA, MQTT, Modbus, REST interfaces to make changes to the product without having to modify the PLC. Now, at the end of the day, the outcome at the sensor level is exactly the same. The sensor is set up to do something that is specific to the process. The major difference is that I don't have to use the PLC to do that any longer. I can use modern high-level languages that are that make it a lot easier to make these changes and then get it down into the sensor via these technologies. In parallel, I should mention this. This requires zero additional wiring, and I have some pictures that show that. So here is an example of an IO-Link master, actually 2 IO-Link masters, and a number of products that are connected to those. And these products, they feed data into the master, and these IO-Link masters make this data available to the PLC. The PLC could be essentially any type of PLC. We really don't care. We're very sensor or PLC agnostic. Could be a Siemens PLC, Rockwell, Mitsubishi, you name it, any type of PLC that talks one of the supported higher level protocols of these IO-Link masters. Now this parallel data channel that runs on Ethernet using the idea and the concepts of the flat IP networks, they can now retrieve any of these additional data points that these sensors may provide. They can retrieve other data, they can retrieve exactly the same data as the PLC already gets, and they can take care of configuration and diagnostics. And I should mention again, without having to wire anything specifically to these products. So this is what the end picture is like. From the field to the PLC, we go the standard route via these real-time control networks, Ethernet IP, Profinet, you name it. But to the cloud, we go in parallel utilizing IoT-centric protocols. And the multi-link technology that we've implemented here allows us to do this in parallel. So that's that part. The other part that has to deal with, or that covers the enhancements to sensors is the digital nameplate project Icebreaker. Icebreaker was an event or an attempt by a number of companies to prove that we can have instance information about a specific product available on the internet in an easily retrievable format. So instance management, digital nameplate, and according to IEC 61406. So what does that mean? That means that a product will now have a QR code, and that QR code is a link to a database, and that link is specific to that product. So 2 items that look exactly the same, for instance here, a photoelectric sensor, will not have the same QR code because they are ultimately different instances of this product group. So if you want to, I'm going to leave this up for a second. You can actually take a photograph with your smartphone of either one of those 2 codes, and they will lead you to a page that is specific to this product. And I'm going to keep going on 1, 2, and 3. So hopefully someone has done it. What that will do is it will load this page, and this page on first glance looks Looks very much like the standard page one would find when going to our web page. But what is different here is, as part of this trial, we now show the serial number and the year of construction of this product. So right now, this is, in my opinion, not very pretty, but the point was, can we set everything up behind the scenes so that a customer, a machine owner scanning that QR code can come to the page, can retrieve all the information that is required on a family basis, so data sheet or approval certification or software associated with this product, but at the same time have this very specific serial number and year of construction information. Now, this is not limited to those two numbers. We just use those out of our internal database to prove that in principle it's possible. There's a lot more information we could put out there. We don't right now. So this is just the starting point of this project. So this is the digital icebreaker project, digital nameplate. Now, as a machine designer, you can have access to this information and you can turn that into your own information that you would provide to your customer. So it follows the onion shell idea of the digital twin. Take some information, add more, add more, add more, and make the onion grow. Last section I want to talk about is a few more examples on sensor advancements and how they help with respect to predictive maintenance. What can these new products in conjunction with Multilink really do to enhance processes? So first example, starting simple, photoelectric sensor. These sensors tend to have digital outputs. Let's say these boxes fly through the beams, and digital control needs to know there is a product or there's no product, and some action will take place. So one thing that we have in all of these products is a number we call access gain. And access gain is essentially a measure of cleanliness of the lens and the reflector. So I drew an artificial line here where left and right is time, increasing time from left to right, and we're measuring the access gain. So if the access gain were to take this type of shape, then we can extend that out and predict when a critical level would be reached, and therefore we can schedule ahead of time maintenance to go and clean the reflector or clean the lens or maybe do some alignment. We can't exactly say what it is. All we know is that the light intensity that we're getting back is diminished. It shouldn't be that low, and it should certainly not be on this trajectory. So let's say we did send this measure out and someone went there and cleaned it. Machine never stopped running. We're back to normal. And then all of a sudden we have such a sudden drop. Now that's a different scenario. Whereas a gradual drop predicts or has to do likely with dust or some other pollutant. When you have this sudden drop, likely we have something being knocked out of alignment. And so now we're definitely going into the critical. We can't help it, it's too late. But we can help maintenance by giving them hints. Please check this. There's a certain likelihood that this has nothing to do with dirt, but it has something to do with alignment. So they fix it, we're going back up, everything is good. Now, what did that whole scenario, that entire story that I told you, what does that look on the output side, the digital output that goes into the PLC? So as long as the sensor is above the critical level, the access gain is above the critical level, the output will function. There is nothing not going to happen as long as we get in before we reach the critical level. Once we hit the critical level, then the output is no longer able to follow the signal. So we fixed this, obviously, so we remain running. And then here, for the short amount of time when we go below the critical level, the output is unfortunately off. So this is one way of helping diagnose and prevent a problem. The other thing that these sensors can do is they can actually measure distances. They're not just looking at return signal, but they can measure the distance not only to the reflector, but also to the object. So if you think about it, when this object goes to the beam, what happens? You see sometimes you measure the distance to the reflector, and then sometimes you measure the distance to the object. So there are two ranges, there are two specific cases that are of great interest. One is pre-collision. What if an object were to be detected that's coming too close to my sensor? Collision is never good because it destroys the product. You have to replace it. You're down for a while. Similarly, if something goes out of range, what could be the reason? Well, one reason could be that vibration shook everything loose and the reflector is not fixed anymore, and it could essentially fall off eventually. So this is a case here where we have a pre-collision. This item is clearly too close. It has not yet hit the sensor, but we don't want it there. This would be an alarming condition. And similarly, when the item appears to be that far away that it's out of range, something definitely did get knocked out of alignment. And very similar on the digital output level, we would see one state when we see the reflector and the other state when we see the object. And depending on the logic that's applied, the output may be on or off. But again, important is the ability to identify problems, potential problems before they show up. Vibration monitoring is, of course, a very interesting and very powerful topic. So I already mentioned that we can configure these products to have outputs that essentially give us worst case scenarios. But we can diagnose more with more in greater detail if we look at the true value of the VRMS that is provided. So the image that or the picture that I drew here is we are looking at two levels. One is, according to that standard, is what we would call restricted operation. You may have to reduce the speed of the operation in order to limit the vibration spectrum. And then above that, once the vibration goes even higher, damage will certainly occur. So if you look at the shape of the vibration spectrum, you can do the same as we did, as I showed you earlier, by extending sort of a projection line. What would happen if I were to keep going on this trajectory? And now we can look and predict that if we were to keep this going, then in 2 days or in 6 hours, we are reaching a critical level. And if we have the ability to check this during a standard break, we better do that. Better check the bearing, better check the bushings, or check the belts, things like that. So from a digital output at the PLC level again, as long as we have not reached the alarm level, the alarm output is of course off. There's no reason for alarming until I reach that level. Once I reach that level, the alarm output goes on. That's all fine for an immediate shutdown of the machine to prevent any further damage, but it's really not so good if I want to make predictions, if I want to send maintenance out to do something during regularly scheduled intervals anyway. So this would be a much more powerful method. So let's say again, they fixed it and the world is good because everything is now back in the normal spectrum of vibration that we expect. So let me propose 3 takeaways from what I'm trying to talk about. Modern sensors allow the separation of control and diagnostics. And not only can we control it or can separate it, but we can also feed that information to different systems. And by utilizing our multi-link technology, we can have control going to the PLC and diagnostics going to cloud structures or other type of PCs that have much more power, computing power, and can run predictive models. And then the component that is involved in all of this is clearly IO-Link. IO-Link is the new standard sensor interface in the market. It is growing by leaps and bounds. And I dare to say that there will be participants in this webinar that already use IO-Link and may not even know it, because IO-Link has been around for 10 years and a lot of product has been designed around the IO-Link standard. So that's the conclusion of my presentation. Thank you very much for listening, and I understand we'll be having some Q&A now or after Brian's presentation.
Yeah, we'll do some Q&A now. Thanks, Helge. So yeah, if anybody has questions, go ahead and please use that question, the panel on your go-to screen. We've got about 10 minutes if we need it for questions. I'm curious, Helge, you talked about IO-Link being the new standard. What percentage, I guess if we speak strictly metal forming, or I know you guys sell into all kinds of markets, percentage of companies that are using IO-Link, and is it going to be 100% in 5 years? What's the market look like for IO-Link? Where we're at today and where you see it going?
Now, IO-Link started with higher end products because it requires a microprocessor. So the first types of products that were used were photoelectric sensors that always needed a microprocessor. Recently, the advancement in terms of chip price, and when I say recently, I'm actually talking pre-pandemic, so because right now everything is a little out of whack, but the trajectory was that microprocessors have gotten so inexpensive that we can even do this on inductive sensors. So there is virtually no product type out there that does not utilize IO-Link. Speaking for our company, roughly 90% of all developments are including IO-Link, and the other 10% is safety, where IO-Link is not yet. There are ideas to get safety into IO-Link, but we don't. The standard is not really fully defined. So I want to say IO-Link will be 100% for these inexpensive low-level products. That doesn't mean that cameras will be on IO-Link or products that have the need for very, very high data throughput, LiDAR scanners, for instance. IO-Link is really not the right product, the right technology.
Okay, good. You said metal formers should perform sensor data analysis outside of the PLCs. Why is that?
Well, the reason is that if you limit the PLC to doing the essential machine logic, your PLC code becomes much simpler. It's much easier to maintain. And also, if there are, as time goes on, advancements on the sensor side to make use of those, if you route the information through the PLC, that would mean that you have to touch the PLC code again. If you go the multi-link route and you keep logic to the PLC and anything else via this additional path, you can make these types of modifications without interrupting your process even a single second. You can get this information out without shutting anything down, no download. You debug under full operation because you're not impacting, you're not influencing anything that the PLC needs. You're only retrieving vibration spectrum, or you're retrieving this access gain data. So you keep running and you can make improvements at any time you want.
Okay. In the slides, like slide 20, I think, when you talk about retrieving sensor data from the OPC, UA, or MQTT, what role does the PLC play when retrieving that data?
The PLC really plays no role. The PLC performs, it looks at the process data and everything else, MQTT, OPC UA runs in parallel. There is the PLC essentially doesn't even know that something else is out there getting part of the data stream generated by the sensors. So that is really the power that you can do this at any point in time. You can even start without it. But the nice thing is you're not limited. If I have the time, if I don't have the time today to implement some sensor diagnostics, okay, so I just run the logic. But as soon as I do have that time, I can get into that part of the project and do more and more and more until my needs are met.
Good, thank you. Any more questions for Helge? The digital nameplate that you showed, go back, go through the kind of sensor-specific information that will be accessed when you scan that QR code.
So the Icebreaker project was concerned with set up a structure, an IT structure, so that information can be provided to a user. In the end, it is completely up to the manufacturer of a product what information they put out, because the QR code has only two pieces of critical information. One is the web location where the information is being processed, and the second is some unique identifier, so the serial number. Once that serial number is being sent to our website, to that particular web link, then we're going into our ERP system and we retrieve information. We can retrieve, as I showed you, we retrieve, well, we already have the serial number, but we retrieve, number one, the manufacturing time frame. But we could go to any length, any detail that is required. We don't know exactly where the needs will be of the market. It is too new for that. But from this point forward, it's just a matter of, if we have the information in a readily available format, machine, or in a communicatable format, we can make that available on this web link. There is no limitation, because we're only receiving the serial number, and everything else is then retrieved from a database.
Gotcha. Okay. Question is SPE. Will it infringe on IO-Link's place in the market? What's the role for SPE?
What was that?
SPE.
Oh, single point Ethernet, single pair Ethernet. Very interesting. Very interesting. The IO-Link community is thinking about expanding the reach of IO-Link as a communication method to single pair Ethernet. So they would serve different needs. Number one, SPE has, strictly from a cabling point of view, much more range. An IO-Link cable is up to 20 meters long, whereas SPE can be 100 meters long. That's one part of it. So there could be a practical reason why that is advantageous. And the other part that it will bring is SPE is shown or is utilized in intrinsically safe applications. So we could extend the utilization of IO-Link as such into hazardous areas. Those are, in my opinion, the two major components. But otherwise, it's almost like, think of it this way: when you plug into your computer in the office, you're using Ethernet. When you're using wireless, you're using really, the outcome is exactly the same, but the data is transmitted very, very differently. But you don't care. All you need is when you go to your bank and you want to do online banking, that you have a secure connection and you get what you need in terms of the data. And this is very similar. IO-Link being a 24-volt signal over a 3-wire connection, or being single pair Ethernet, doesn't matter at the end. Each one has its place, I believe.
Very good. Okay, I don't think we have any further questions for you, Helga. So, as always, thank you so much for a really informative, useful presentation. I hope everyone enjoyed it. So thanks for being with us today, Helga.
Thank you. Thank you. Have a good day.
Yep. So next up, and our final presentation for today is a case study. This one's on the battery can manufacturer H&T Waterbury. H&T recently leveraged IoT technology to avoid unplanned stops of one of its high-volume production machines. And as a result, the company's been able to eliminate scrap issues and unplanned overtime and a lot of related downstream additional costs. Our presenter is Brian Sepah, the CEO of SensorTrex, who worked with H&T Waterbury to develop its IoT solution. Brian's got more than 20 years of experience in manufacturing and has been featured in Inc. magazine, St. Louis Business Journal, and the St. Louis Post-Dispatch. And Brian also has won numerous technology awards throughout his career. So please welcome Brian.
Hey, Brad, thanks. So Brad did a great intro for what I'm going to talk about. So we're going to talk about this case study that we did with H&T Waterbury, who is a really high volume metal forming company, and a little bit about our solution and what the initial problems were that they solved. And then we'll also talk about some different benefits that they've gotten beyond that. And on these things, I'm an open book. So let's ask a lot of questions towards the end. I'm happy to answer. You know, I'm sure there are things that I'm not going to cover in the presentation. So who is H&T Waterbury? They're based in Waterbury, Connecticut, and they're a manufacturer of battery components. They're part of the Heitkamp Thumann group, which is the world's largest battery component manufacturer. This one plant produces billions of parts a year, and what they're making are these little battery canisters. So it's the metal outsides of AA and AAA batteries. It's pretty highly automated process. Would have to be to make billions of these per year. And we're on their stamping lines and also the finishing lines inside of their plants. I think it's about 18 different lines right now. So the original challenges that they had when they reached out to us 2.5 years ago, was a lack of visibility of what was happening inside of the plant. They had a lot of manual reporting, you know, so production, downtime, scrap rates, all that stuff was being reported on paper, summarized into Excel, sometimes, you know, tacked up on whiteboards and communication boards. And a lot of companies do this. I'd say the majority of companies still do it this way, and it works. The challenge is you don't really have timely access to the data, so understanding what's happening now is a little bit tough. Also, looking at trends over time can be hard if you're trying to pull together, like, let's say you want to understand what's happened over the last quarter. Well, you're going to have to pull together, you know, 120 different spreadsheets or tabs to be able to summarize that data. It's a lot of work. And the other problem is that if you're looking for really fine-grained issues, so like micro stoppages on a line, so think like a stop of 5, 10, 15, 20 seconds, you're not going to get all those because operators are not going to write down every time a machine or a line stops for 15 seconds. And there's an interesting quote here by Spencer Cushman, who's the director of operations for this site and our primary contact and executive sponsor for this implementation. He said, before implementing SensorTrex, we knew there was a problem. We just didn't realize how bad it was until we started collecting the data. So this is a very common scenario. You know, we work with a lot of companies that have this same view. We know we have inefficiencies in our processes. We just don't know where they are because we lack the information to really find them, right? We just don't have the ability to do it. The granularity is not there, reporting on Excel and paper. Some people even feel like the paper method is almost the same as not reporting at all. So what is SensorTrex first? Let's just talk a little bit about that so it sets the stage for how this whole process works and how we gather the data. We call SensorTrex a manufacturing productivity platform. The idea is that we're trying to provide more timely access to production data. So things like part counts, production rates, You know, am I going to hit my due dates on my jobs based on, you know, the targets? And then also giving you the information to trend out over time and find some of your larger inefficiencies and be able to eliminate those. And as part of this, it's removing all that manual data collection process as much as we can. And so to do that, you have to collect data automatically. There's two ways that we can collect data. The stuff that Helge was talking about, if everybody could just implement that, it would make our lives a lot easier. IO-Link's a really great technology, and a lot of the things he talked about would make connectivity to machines a lot simpler, but obviously you're not going to rip out all the controls in your machines and drop that stuff in right now. One of the ways that we do it is we retrofit in a very similar manner to what Helge was talking about, equipment with either sensors or nodes that can pick up outputs on the machines. So essentially bypassing PLCs and looking at things like, you know, if there's a relay that can tell us a press is stroking, for example, that's enough to drive a whole lot of information inside of the software. It's really good for older equipment where you don't want to or can't pull data out of the PLCs, but gives you good visibility. Second way we do it is talking directly to PLCs. This is what we did at H&T. We'll talk about how we got that connected. The beauty of talking to sensors and the PLCs and actually even having access to some of the logic in the PLC is that you can map that data to downtime reasons. So when the thing that almost everybody wants when you implement a system like SensorTrax is, I want to know why the machines are down, and I want to know when they're down and how often. In the case where you have sensors or you're just, you know, counting parts as they're going through a machine, you know when it's down and when it's running, but you don't necessarily know why. An operator would have to tell you why. But when you're connected to the PLCs, if they have the right kind of information in it, we can derive the reason why a machine stopped, automatically categorize the downtime reason, and it's just less information a person has to put into the system. Third way is manual data collection, where anything we can't get automatically, you just enter into a HMI, makes it easy to do. So, and then all that data is collected and it flows up to the cloud where you get different visuals and things like that, dashboards, scoreboards, operator interfaces, those kinds of things, so that you can really run your business based on that data. And then we can integrate with ERP systems and maintenance management systems as well. Depending on time, H&T integrated with their maintenance management system, which we can talk about too. So how do we do this? So when the project first started with H&T, they wanted to start in their finishing area. So it's where they put coatings and different things on these canisters, these little battery canisters, and it's where their bottlenecks were. So they knew that if they could figure out what the problems were there and solve those problems, that would give them the biggest bang for the buck for the project. So all the finishing lines had Allen Bradley Compact Logic PLCs. They contained a pretty good amount of information that you could use already to figure out some of these issues. So, you know, there were faults inside of them to tell you if there was a problem. We could figure out machine state. We could figure out counts, how many canisters were being made. All those kinds of things existed inside of the PLCs, but they weren't connected to a network. So H&T Waterbury did not want to run Ethernet to each one of those PLCs. They thought it would just be too expensive and too challenging based on their environment, but they had really strong Wi-Fi in the plant. So what we did was we got these little Moxa boxes. Moxa box is a technical term, not really, but that's what everybody calls them. It's a company called Moxa, and they make conversion boxes. So they can connect Ethernet to Wi-Fi. They can connect serial to Wi-Fi. So these are really good tools to connect PLCs that maybe you can't connect directly to your Ethernet network to a Wi-Fi network, or convert serial onto an Ethernet network to be able to talk to those PLCs. So they communicated over Wi-Fi back to a central area where there was a SensorTrax gateway. So there's a gateway as part of our service that can talk all kinds of different industrial protocols. In this case, it's Ethernet IP, and it handles the communication directly with the PLCs through these devices, transforms that data into something that SensorTrax can understand, pushes it up to the cloud over another Ethernet connection, where, again, they get all the different tools that they use to kind of solve these problems. So, and this is an out-of-the-box solution. The gateway can talk tons of different protocols, so it can be Ethernet IP, it could be Modbus, it could be OPCUA, MT Connect, Siemens, S7 protocol, like you name it, we pretty much support it. So to dig a little deeper into what they were getting, as I mentioned, we were communicating with the PLCs using Ethernet IP to pull data out of them. The PLCs were connected to, the sensors and the inputs and outputs that actually run the machines, that control the machines. The machines were already stopping based on certain faults that they knew were going to cause, quality problems and scrap issues with the product. And so we started pulling those faults. When the machine would stop, we'd read out a certain registers to know why, and then map those to specific downtime reasons. We were also gathering other data, so oven temperature, air pressure, positioning of different sensors and actuators inside of the line to be able to understand other problems that could be happening as well. So it's about 14 data points per machine. And then also the counters, so counting the cans as they're going through the equipment as well. So this setup process was relatively fast. I think once the Moxa boxes were installed and the network was set up, it was set up over the course of just a couple weeks to get the data flowing and to actually validate the data. So once that's all set up, then they set up the software to start to give them visibility into what's happening. H&T is somewhat unique in that because they're highly automated and high volume, they don't have to have any input from an operator really for anything. So there's no operator screens out on the floor. So what they deployed so that people can see what's happening on each of the lines that we were monitoring are scoreboards. So scoreboards are just big TVs. We have an app on the Amazon Fire Stick. You just plug it into the back of the TV and you can display in real time how each one of the lines is running. So you can see here, this is a picture taken shortly after they went live. We have, 5 different machines. They're all up. This is their OEE, and it's color highlighted, whether it's green, red, and yellow. And then they have some other metrics that they're tracking at the same time. So what this does is this gives visibility to the operators and supervisors on how all the lines are running. And if you're walking the floor and you look up here and you see, okay, line 4 is in the red and 5's in the yellow, you can walk over and talk to the operators and figure out what's going on, so that you can start to solve these problems and understand the issues now rather than waiting until tomorrow, when you might find out about it when the Excel spreadsheets and Excel reports go out to the team. So they also developed some dashboards to give them better visibility into how things are trending over the course of a day, a week, a month. These are just examples. I couldn't pull their real screenshots. They also set up automated reporting, so you can email out dashboards on a regular schedule from the software. So what they did was they set up a daily production report that would show by line the top downtime reasons, how long it was down, how many times it stopped, what was the average duration. And this is where they really started to see what was going on out on the floor. Because what they found out was, we'll go into this right now, but they had a backwards can problem. So in these emails and these dashboards are really what brought it to light and showed them like how big of a problem this actually was. So what's happening is backwards is kind of a misnomer. It's upside down. The finishing line sprays a coating inside of this canister. And what happens sometimes when the machine stop is a can flips upside down. And so you have the bottom of the battery canister pointing up, and you have, the open side pointing down. And if you don't get that coating inside of there, it's a bad product. The customer has to reject it, and it becomes an issue, right? If you're shipping inferior product out to your customers. And so what they figured out was they knew that this was a problem, right? But as Spencer's quote said in the beginning, they just didn't know how bad it was. What they found out was certain coding machines were stopping up to 1,000 times a week on a single machine. And it didn't take very long to reset this. It took 15 to 20 seconds to fix, especially if an operator was right there when the machine stops. The machine knows when the can goes upside down and it stops automatically to make sure it doesn't make a bad part. So the operator would walk over, flip the can over, walk over to the controls and hit start again, and the machine would start up. So 15 to 20 seconds. But you multiply that out across 4 different machines, it's like 18 hours a week. So it's a lot of time being spent with these little micro stoppages that they knew were there, but they didn't know how bad it was. And what was interesting was if once they got this data, you go and talk to the operators and they would say like, does it really stop this much? And it's like, yeah, it's a huge problem. But the operators would never say anything because they were trained to fix it and they were told that it's a big problem and it stops all the time. But sometimes that doesn't always rise up through the organization to be able to get fixed. And to kind of mitigate this stuff, they were running overtime on Saturdays because, you know, this is 18 hours of lost production time. It's a lot. So, you know, and they had trouble trying to figure out where the problems were coming from, which is why they implemented sensor tracks. So how do they solve this? So what they did was they set up a Kaizen event to figure out this problem. And they decided that they would get everybody, maintenance, engineering, you know, the operations team together to do this. And they made little tweaks to the way the cans went through the system and how, you know, like these air jets work and all kinds of different things. And they iterated on it. And they looked every day at how many backwards cans they were getting after they made a change. Is it going up or is it going down every single time? And this is really how they fixed it. And this is really how all of our customers fix these things. It's, you know, you identify a problem, they either put together a Kaizen event or whatever you want to call it, a group of the right people to help solve this problem. And they keep trying different things to iterate on and fix this. They watch the data every single day to see if what they did actually fixed the problem. And over time, they were able to do it on one machine, and then they fixed it across the board. And ultimately, what they were able to do was reduce downtime by 73%. So they had 73% fewer backward can downtimes, which was their biggest issue at the time. And so this gave them back something like 15 hours worth of production a week. You know, that weekend overtime stopped to be able to deliver on this. And I mean, you can imagine the amount of money that was saved by fixing this one issue, because we're losing 18 hours of productivity every single week. And they're a 24 hour a day, 5 day a week operation. So pretty big improvement there. And really this came from the continuous improvement team. So, you know, everyone in the organization has visibility into what's going on because of the scoreboards. And then different folks from supervisors, continuous improvement and operations get the automated emails out of the software so they can see on a daily and weekly basis what's going on. But the continuous improvement team were the ones that were digging through the data and finding the issues on where to focus, and drove this improvement. Put together the Kaizen team, iterated on it. They were the ones watching the data every single day to see if it was going up or going down, and making things better. So they found some other issues as well that were kind of interesting. So kind of going beyond the backwards cans, they had a machine, it was another one of these finishing machines that was throwing a fault for 6 months, and they couldn't figure out what the cause was. The part of this equipment that was causing the fault was it had something to do with removing like paint fumes or something from the line for these coatings that are put on there. And the machine would throw a fault all the time, saying that the filters were dirty. They were changing the filters all the time. When you change the filters, you'd lose about 2 hours worth of production time because the machine's got to cool down before you can take them out. And then once you put them back in, it's got to heat back up. And so again, a lot of downtime associated with this one particular situation. And the problem would happen kind of randomly. So what they did was they set up alerts inside of sensor tracks that said, hey, anytime you see this certain alarm through the PLC, notify all these people. And it would send out an email, and then we also have a mobile app, so they get pinged on their mobile app to say that, hey, you know, we're seeing this fault again. And so again, put together a team, Kaizen event, and tried to figure out what the problem and the solution was. So they iterated on a bunch of different things. You know, they talked to the manufacturer of the furnace, they talked to engineering, they talked to maintenance, and they would try something and then see, did we get alerts yesterday or not? right? And that would kind of be the judge of whether or not it was a problem. And what they ended up figuring out, which was something simple, was it was a dirty inlet line and it wasn't clean. They did clean it throughout the process, but it wasn't cleaned enough to be able to work properly. So they used some pipe cleaners and a bunch of different things to be able to really clear that out. But everybody was on this because they would get bugged by these alerts pretty much 24 hours a day. The guy that was running this project, you know, he said he would look at his phone to see if he had gotten any before he went to bed, and he'd be really happy when he went to sleep if he hadn't gotten any, right? Because he thought maybe that they solved that particular issue. So, you know, at the end of the day, it's getting visibility into the data that's going to surface these problems that you can then work on and then use the data to figure out whether or not you've solved these things. And they've, you know, kind of replicated this across the plant. So we've expanded out from the finishing area now into stamping. And the way they use this every day is really a replacement for that manual, you know, data collection process and determining whether or not they're hitting rates on all these different lines every day. And if they're not, why not? And addressing it as soon as possible so it doesn't go on too long, and so that they're supporting their operators and, you know, helping solve their frustrations. So one of the other things that H&T's done, and I don't have case study information on this yet, is they integrated with a maintenance management system. So since we're collecting all of this data, we're collecting cycles, like how many parts were produced, you know, every hour, every day, every shift, those kinds of things, and also how long the machines have run. We can send that data over to another system like Fix, which is a maintenance management software that can then trigger preventative maintenance activities based on condition. So it's a similar solution to what the earlier presentation was talking about, when, you know, you want to start doing maintenance when things maybe go wrong versus just doing it all the time, not necessarily go wrong, but are trending in a bad direction. So when you think about doing maintenance on presses or these finishing lines, if they're not running very often, you don't have to do maintenance as often. If they're running all the time, you're going to have to do it more often potentially than the schedule, calendar-based maintenance would tell you. So the idea here is move to condition-based maintenance. Your equipment can stay up and running for a longer period of time, and you only do the maintenance, preventative maintenance activities when you have to, versus when maybe it's not needed. So you get more productivity out of your equipment, and if you're super high volume like these guys, that can really make a difference in terms of output. The other thing I want to mention is Brad in Metal Forming Magazine did an article about H&T that has some different details than what I shared today. That's another QR code where you can take a look at that article. And then we did an interview with their continuous improvement manager, who's no longer there, but the person that kind of led the Backwards Can project on video. And he shares a lot of additional details about, you know, technically what the issues were that they fixed and how they did it and how long it took and stuff like that. But those are mostly, you know, internal, engineering things that are very specific to H&T Waterbury. So I think now is a good time to stop and ask for some questions if we have any, Brad.
Yeah, thanks, Brian, and thanks for the article link. Yeah, it's in our July 2020 issue of Metal Forming, which you can find on the website, and obviously use that QR code there. I think Spencer told me, Brian, they've got the system now installed on 14 machines total. Does that sound right? Six coating machines and 8 transfer presses?
Yeah, I think we're up to 17 now, but yeah, that sounds.
Is it 17? Wow. Okay. Yeah. Okay. Yeah, and he spoke a little bit about the computerized maintenance management system and how seamlessly it integrated to your equipment. What did he say? He said moving from a time-based mindset to a to an account-based mindset has made a big difference, and they're using then the computerized maintenance management system to trigger automatic work orders, which is kind of cool. All right, so any questions for Brian? What sensors are available to measure lubricant oxidation? Do you know? And maybe Hug is still on the line as well. I don't know. Either one of you want to talk about lubricant oxidation and if there's sensors to measure that?
I don't know. That one's a little bit outside of what we deal with on a regular basis.
Yeah, neither do I. That's not something that we would be involved in.
Okay. I know we've got a couple of lubricant experts on the line right now. Maybe they've got an answer. So, Brian, the future of IoT in manufacturing in general, and your experience with stampers, what role do you see that playing? Is it similar to what you've done at H&T Waterbury? Do you see something different from your window?
Yeah, I think that IoT now is, people are looking for outcomes, right? The hype and excitement over connecting things, I think, is over. And now it's, how is this really going to help me on a day-to-day basis? And so, where we used to position ourselves as kind of an IoT company, now it's much more, you want to automate production reporting, right? I need better visibility into those things. And IoT is a part of that. It's an enabler for that to make it a lot easier than it used to be. But it's not kind of the core thing. So that's what we're seeing is customers not asking for IoT, but they still ask for OEE, help me automate my reporting, get me better visibility. I want to understand if my machines are running or not, and why not. That's really what we're seeing now.
What do you see as some of the bigger roadblocks to implementing your solution or any IoT solution, really? And how do you mitigate some of those roadblocks?
The biggest barrier is getting good data in a timely manner. So, figuring out how you're going to pull data off of these machines and then getting good quality data in 3 months or less. Because if you don't, people lose interest, right? These types of solutions are not like ERP. I mean, I'm sure many people on the call have gone through ERP implementations. They probably have gray hair or less hair because of it. And these are not like that. People have very short attention spans. Like, if you can't get me the data, I'm not really interested. So making sure that you can quickly get that information and get something fast and start to show value is really important, because these projects are all about momentum. So if you can get something, this is what Spencer did. We started, I think, on either 1 or 3 coding lines. We got it set up, I think, within a month or so. We got some good data, kind of proved out that we could get the data, expanded it out, and that's where they started to see this backwards can issue. And so you're just building on momentum this whole time and layering in more and more machines and more data as time goes on. So that's the biggest challenge. The second one is making sure that you have an executive sponsor who can help create focus on the project. That's the best way to be successful. Sometimes driving these things from the bottom up is tough.
Yeah, do you know it? With in Spencer's case at H&T, what type of support and buy-in he had from? Obviously, he must have had some kind of buy-in from management there.
Well, I think they had kind of a corporate requirement to start collecting this kind of data automatically, and so he runs that facility. I think at that point he was general manager, not director of ops, but so I think he had full authority to make that decision.
Yeah, and so they're obviously really highly automated, high volume. Any type of interruption at all is going to cost them a lot of production. What if a company's not quite as automated or high volume as H&T Waterbury? Where do you see companies, maybe a little bit lower volume or less automated, leveraging this type of tool?
They do the same thing. The real big difference is you just have to get a little input from an operator to get the same level of visibility. So, we have machine shops that make different stuff every single day. And they really just care about utilization of the machines. Like, we have an aerospace customer who really just cares about utilization. They don't care what they're running. They don't care how fast it runs. It's just, did it run, right? And for how long?
Mm-hmm.
So, you can do those kinds of things with no input from a user, and then you just layer in additional detail, but it's relatively minor if you set it up correctly. So you can get the same level of detail, just having an operator a couple times a day, change from one job to another, which you may already be doing in your ERP. So we could piggyback on that, and then enter a downtime reason here and there for why the machine's not running. So you can do the same things. It just requires a little bit more input from the operators, which requires a little more change management and a little more convincing, but it works very well, highly automated or not.
Sure. Very good. Okay. Any more questions for Brian? If not, thank you, Brian. Thank you very much for being here. Appreciate the presentation, and to H&T Waterbury for sharing letting you share their story. That concludes the session for today. Remember again that all the archived recordings and the PowerPoint presentations will be available on our website in the next couple of days, maybe early next week. Everyone will receive an email to give you instructions on how to access those. Join us tomorrow morning, please, for our final set of webinars, and we'll hear from Michigan Manufacturing Technology Center about its Real Factory 4.0 and how it's helping small manufacturing companies implement smart manufacturing technology. And then we'll hear from Hinook Kim. I think a lot of you know Hinook. He's the director of EWI Forming Center, and he's going to talk about his vision for Industry 4.0 specific to metal stamping, specifically the use of sensors to monitor material properties and die friction response, elastic tool deflection, and press dynamic characteristics. So thanks for joining us. Thanks to Brian and Helga again, and we'll see everybody tomorrow morning at 10 a.m. sharp for the rest of our sessions. You can close your browsers, and thanks for joining us. Have a great evening.
Thanks, Brett.
Thank you.